Welcome. In this particular episode, what we are going to do is try to implement a fix for a problem that we are having. When we are doing compact garbage, we find ourselves having the same pointer pointing to two different objects. First is the actual object, which is part of the vm.object chain. We also find ourselves having the same pointer pointed to a value array. So it looks like the VM objects pointer is wrong because we did some update there after the compacting. The values that it points to should have changed to a smaller value, but it still points to 3700. So that's what we're going to try to fix in this particular episode. Before we start, let's open up the log file. Taking a look at a copy of the function, it looks like in this case, what we are doing is we're calling right array on A to E38, and that basically causes to call resize value array on A3700. Let's take a look at the function write value array on value.c line 32. Right, the function values the line, the found line is probably wrong. This is probably line 29. We somehow set, we somehow call value array with A to E, and somehow ended up calling resize on A3700. This looks wrong. We are not sure whether it's a debugger printing out something wrong, or the debugger pointing to the address that's already been changed. But let's print out the stuff to see what we're actually dealing with. So write value array. Printing ALX of the array. This is the array pointer. In the resize, we also print a similar thing. And in this case, once it's done, resize have two prints, one for before it's passed in, one for after it's passed in. Same for write value array. I should expect two values here. Since the function went through right value array. Let's look through. Let's look through right value array in the GDB. Build the file. Running in GDB. Running out the test. Segfault. That's the check. That's the sim error. We're trying to mark object 08, which is wrong. So let's put a breakpoint on right value array. Running the test again. Right value array. This is the first time I start writing. Continue. And the first time I start writing, I already die. So in right, it prints up both. In right, it prints up both as 2E38. And as we continue going down, we don't even get to finish the function. So why is that the case? Looks like we may be swapping the values maybe a bit too early. How do we fix it? To fix it, what we do, to try to understand what's the problem, let's take a look at the backtrace. So this is the first time we write this value array and never even finishes running. In the resize, you probably try to reallocate. Actually, I think it did finish running. Because the temp actually changes. The temp actually changes here. We actually set it. Line. Okay, let's take a look. Line 22 or resize. Somehow the record is A3700. And not A2E38. Why is that the case? Means that the array has actually changed. So what are we doing here? We have to resize. The pointer actually changed, and there was an error in the grow array. But let's confirm this to do a 00 new values. Let's see whether it actually prints. I want to know where we actually ran until. Actually, in this particular case, I just need to run prediction. It should print our 00. Right, we actually swap the array and we point it back. So where is actually the segfault running? On line 22. This is running here. But how come I have this? Resize array 00. What's going on? A3808. That's supposed to be the address of the new memory. So on line 22, let's look at the macro. Grow array macro. It's basically reallocate of a certain pointer. And what's the pointer being passed in? The pointer being passed in is basically the one that array already points to. So allocate is already pointing to something. How come allocate is already pointing to a pointer when the size is 0? Right, there's something weird. So let's have two prints here. One for the pointer of the values, one for the new value. Right. Yes, build. Then running GDB. Let's run the full test again. What do you have this time? For some reason, they are printed out of order. Somehow this is being optimized so that it will print before for some reason. But whatever the case, they point to the same thing, which may or may not be correct. Let's print this way outside before everything happens. Let's look at the values pointer of the array function before we even run the loop. GDB logs, run my test. So before I run my loop, it's 0. So this is correct, right? Where the array refers to 0. I print out my stuff and I basically call reallocate to give it some memory. Why did that? It has some value here. Why is it that he has some value here? How about when it's inside this? Right? What about when it's inside here? Does array 00 has any value here? Right? I expect it to be 0, but may not be the case. Run the test. Take a look. It's indeed optimized away somehow to print in this manner. So as long as I'm outside of the loop, somehow I'm 0. Inside of the loop, somehow that just messes it up. Okay, so let's do something a bit different. Okay, let's do something a bit different. Let's save the value of, and assume we just need to grow capacity one time, which may or may not be correct, but let's just do that for now. Okay, running it on old values. Did value change? Right, okay. Maybe it's pointing to a new thing because the array address changed, but the array address did change. So it's kind of weird. Okay, let's do this. Okay, let's print an additional one. Dash. To actually print the value of the old values pointer. Okay, build. I actually passed 0 in now. Now I'm passing pointer 0 in. And size 0, 128. I'm actually calling pointer new now. So that's strange. Somehow we are pointing to something that we are swapping around. But is this really the issue? Is this really the issue? Collect garbage, sweep, mark. Let's look at the garbage collection function. Memory 299. This is basically collect garbage. Let's look at where we actually compacted memory. I think it's because of a compacted memory and we forgot to swap. Because if you actually print vm.objects, it shows 37 EA. If you do object next, it actually shows 37. And if you actually print out 37 and do object needs again, it basically a object next actually points to 08, which is wrong. The reason why it traces to 08 is because in the resize array we actually change the value, change the size to 08. But the weird thing is it actually points to 08. So if we previously when we view the 3700 as an object string, we actually see that it refers to the string clock. So was there actually any compacting done? Okay, let's do something where when we do compact swap garbage compact, we actually try to not run it. Let's see what happens. It shouldn't have any error if that's the case. Right, as expected, there's no error. It actually prints out 10 properly. Where does it print out 10? Right, it prints out 10 here properly. But when we enable garbage compact, what happens is we do the three things. We compute how much we need to defrag. We move all the memory over, then start swapping the pointers. And in the swapping pointer process, we basically messed up a bit. So building it again, running in GDB. If we run the same test, basically have the same mark that we are calling with our object 08. This garbage compact function. Compact, move, and swap. We somehow swap. Compact swap. What does compact swap do? It actually swaps. This is the memory that's being swapped. Okay, let's look at compact swap 0. So what does the print actually mean? So compact swap 0 dash swap AG dash swap this is memory.c390 is basically me passing the original. So the original pointer is that's strange because this is a pretty weird swap table. This looks wrong. Marking key. The few times 3700 is used. Oh. Could we be that we swap it multiple times? Okay, maybe. You see a bit of a weird piece of log here. A3700 seems to be not changed. A37EN as well. Then we see marking key A3700. Is the order the sort of pointers correct? It's very strange. So let's check it out. Okay, in this case, let's check. Okay. Did we swap the pointers multiple times? Okay, how do we check? Let's look at the code for marking key first. Marking key. Okay, where would that be? In table.c, we actually mark our keys, right? In marking key, we mark the object. Basically, we swap the values. But according to the table, the 700 swap is nothing. Okay, how do we know it's correct? Okay, we do want to mark this key because we want to update this value. Right. For some reason, is there any compacting done? There's no compacting done. But somehow this is printing something weird. So to be fair, there's no compacting done. There's basically no compacting done, but okay, let's copy a bit more detail. Okay, on second look, what is it? Yeah, we only have Okay, let's check. Looks like we have no compacting done. Oh, how come it's pointing to a different thing? And looking at the logs, we here's the before memory. Let's paste it in the logs. This big chunk of showing which is the account used. And one more segment. Okay. Right. The tree is selected. Right. The tree selected. There should be no compacting done, but I have a swap. So that's wrong. Let's look at the part for getCompactSwap. If it's not compact swap, return pointer done. If it's now pointer done, okay, what am I doing here actually? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until 32. So global compact index. Okay. So before we print the swap, let's print something else even better here. Okay, maybe it's is it a division error? It can't be. That looks like it's a division error. Okay, let's print index. The x2 equals to, okay, this is 0 and 1. Yeah, let's print this as well. Running GDB log. Let's run the test that we have. This is strange. Okay, I'm given a address that's way before. I'm given an address that's way before. Where is this address coming from? Right, this looks wrong. Something shouldn't have been called on. And let me show this. And this is basically my code for getCompactSwap. Right, there wasn't portion of the function that shouldn't be caught with getCompactSwap. Let's check the ones for 887. 887 is 0. Somehow I'm getting a negative. Looking back at the code, why would we ever try to get compact swap for something that is outside of the memory? Let's look at where that is caught. So if we do backtrace, this actually looks quite familiar. 2E38. 2E38 is basically here. And this is the value array. Should value array be part of the global? It technically should. We do see ourselves printing out new memory as well, right? 2E38, 2E38, 2E38. Now this is giving out new memory. 2E38, no. It's not there. We didn't give out the memory, so where did the memory go from? Right, value array p17. Let's look at that. Where did that memory come from? Leaving this print there. vm.global values. Where did we init this? Actually, what are we doing here? vm.global values. Okay, 70. Okay, in vm.c70, what we do is we write array into global values, which isn't on the memory block. Okay, so we also want to do something, because value array could exist on memory block as well. So the correct thing to do here is if my okay, so a few checks here. Other than this, we also have if index less than 0 or index more than, what is the max here? Memory unit, total memory, no. Okay, total memory. Total memory, this is the number of blocks. Right, so this is the number of blocks. So looking at getCompactSwap. So if or more than equals to total memory, I return back the pointer itself. Why do I do that? Okay. The pointer is not part of the memory that we are managing. Okay, so let's try that. GDB logs, run test, 25 closure. Yeah, yes, so now it's a different kind of error. We are marking some other things now, right? So, very nice. We basically fix one bug, and this is a new bug here. So let's take a look at the fix here, right? So what's the issue here? The issue here is that we are calling getCompactSwap on. What are we doing? We are doing getCompactSwap on pointers that are not part of the managed memory. So the fix is to double check that the index is indeed within the range of the managed memory. Okay, this is a new error here, but let's clean up our code a bit first to figure out what to actually commit. So these are the files here. Let's take a look. Memory.c, basically printing some additional stuff, and also the fix itself, we want that. Okay, value.c, some resizing stuff, old value stuff, printing stuff, not that important. Let's restore that. Logs, okay, let's keep it. Let's do a double check. Values, I'm not sure this helped much. It's just the printing error. Logs, that's all, right? Do a double check. Let's build this. Okay, running in GDB again, running with our favorite test here, 25 closure. What we have is a weird error. Let's copy this for a bit. Okay, there's a segfault. Okay. Right, there's a new segfault, and this is the traceback. And looks like we are doing something to the string, and that something is wrong. We'll try to fix that in the next episode. Thank you.